I don't even see him on here.
No, I don't. No, I mean, he's listed as, oh no, he's the host now. So I don't know what happens. Well, I mean, we can't tell anybody else to drink because everyone in Facebook.
Hey, are you guys drunk yet? Dude, so complete Verizon outage. Can you hear me?
Yeah.
Yep.
Yeah, complete Verizon outage at the house. Hold on. Everything came back. I had to restart everything. It came back. Everybody was still there. I was surprised, man. But it was just it takes me that long to pretty much start everything. I figure Mike's going to be like falling over drunk here in a minute.
Applause, baby.
Anyway, I apologize, Brian. We were in the middle of such exciting stuff.
It was supposed to be way better than that. I was still working on the.
Oh, I'm sorry, man. I screwed that up. But anyway, no, we were doing good. I did get my screen working here. This is like super technical glitch night. It shows a lot of drop frames. I apologize if it's crappy, everybody. But
it's way easier when I've been drinking.
So literally just everything stopped all of a sudden, and then it started beeping because OBS Studio and the Ring Central both have warnings about network quality. And then it looks like the phone stopped for a little bit. Then I went to send a text message on the phone to Bill, and all of a sudden I got like 5 messages from people on the phone. It came through after maybe 30 seconds of downtime. But anyway, sorry. I thought, here it comes. Yellowstone's erupting. Guys got your Boogaloo bags ready to go? Yeah, we're up. We're back. It's streaming. Okay. So
awkward moment of silence.
Yeah, well, it's just been awkward all night, man. Sorry. Don't know what's going on. Technical difficulties. I had Verizon issues. So everything here runs off Verizon cell service more at this particular location that I am at. And there's a house cell service here that provides a Wi-Fi hotspot like the expensive Verizon home deal. But when it has to be something with the cell tower or something went down because the phone stopped, the hotspot stopped, and the home service, all three of them. It's not much of a backup plan when they all rely on the same tower. But anyway, somebody's having some problems. Maybe it's overload or everybody being at home. Likely.
Yeah, I mean, I'm seeing a huge issue in the middle of the day with internet quality and just struggling to do basic stuff required to run my retail company. It's terrible.
Everybody's watching the Tiger King.
Oh, God.
I guess that's something I'm going to have to watch. I don't do that because it freaking stupid cell bandwidth is expensive. I don't do that out here.
Did you push everything live again?
Yeah, it's all live. We're back on. You're in front of a worldwide audience of probably 9, 10 people tonight. I'm kidding.
My everything I have on Facebook and YouTube is still saying was live. Let me see.
Oh, they said YouTube is back, but Facebook is gone.
Let me see. YouTube is still not telling me live, but
we could pause it and do it again later, or another day or two. Let's do that. Because I get the feeling that Verizon's going to be screwed. It's been screwed up since 3 o'clock this afternoon. It's just going to do it again. And I can see it dropping frames.
Polished presentation there.
Well, the thing is, there's a lot of really cool things about VE that'd be cool to tell people about.
Yeah, it'd be nice to have a little bit more of than straight into, hey, here's the math, guys, by someone who thought he had 20 more minutes to drink and get comfortable talking.
I'll show him. No, let me try and do some on my end. Let's see if my at least it doesn't have to suffer the crappy network in 2 directions if we do it this way. So hold on, let me get the screen switched up here. I'm running with my portable rig tonight, so I don't have all the wonderful screens and levers and faders. All right, cool. So everybody's that's tuning on Holly these days is familiar with tables that look like this or a little like this. If you have, I don't know if I got any V4 tables on here or not.
God, I'm not seeing your screen on my end.
Yeah, neither am I.
You should hear pretty shortly. I'm showing that I'm broadcasting a live Holly fuel table right here. See me highlighting stuff in it? Or is that not coming out on the YouTube?
I'm watching right on Ring Central.
Oh, you won't see it on Ring Central, bud. You'll only see it on the
okay,
stream.
okay.
I'm not feeding it to the rest of the world. I'm feeding it direct, not via Ring Central, not sharing it with you guys. So you get to just listen, or you can watch on the stream and be about a minute behind. Sorry, I didn't work out that difficulty, that challenge. So long story short, I mean, let's, for simplicity's sake and because it's easier to tune, I'm going to make this a small table. No, I don't want to transfer learning to base on this one. There was no learning in the learn table anyway. You can go back and forth with conversion. Now on the Holly, let's start off at the top. On the Holly, when you're setting up the system, under system ICF, where you're putting in the injector sizes and data and all that stuff, and the setting up your some of your base parameters here, you'll see this top center. There's load sensing, okay, and by default they're on speed density. Do I want to convert? Yeah, let's see if it does an okay job. Maybe updated change in the load sensing. No, I don't want to change the map scaling at all. Let's see if what this did. This is the original. Most Holly tunes come with this speed density configured. And then what you get is a pounds per hour table. Okay. Now, let's convert that to VE, see if it turned out okay. No, it did. Okay, they did a good job converting. All right. It goes both directions in Holly. So you're looking at this pounds per hour table, and here's one of the examples I was talking about. This is roughly 500 RPM, and this is 1,000 RPM. Well, proper tuning shows almost double the numbers. The lower the RPMs get, the more dramatic the fall off needs to be to have a consistent amount of fuel. Look at these three cells. We'll switch it to volumetric efficiency. You'll see they're almost the same. It's only 69%, 71%, and by 1,000 RPM, finally 75% volumetric efficiency, or cylinder fill percentage, I guess, is another way to look at it. How much atmospheric pressure air are you getting into that cylinder? And of course, in vacuum, the throttle's restricting that. The throttle is reducing airflow into the engine, making it have to work harder. So that's why the VE numbers down here at low RPMs and low loads and high vacuum, less efficiency, less airflow going through the cylinders, therefore less fuel to go in with it. This fuel here, or this table here, is just adjusting the fuel quantity, same as it would do on your base pounds per hour table. But I just wanted to talk about why I like the VE mode a little bit better. This is the same table. This one's volumetric efficiency. This is the pounds per hour version of it. This pounds per hour table, to me, especially the three-dimensional view, doesn't really do much for me. And if you notice, you might make a big change. Let's go to this table here. Let's make a big change. 7 or 8 right clicks there. It doesn't even show the spike. Like something's weirdly smoothed about this graphical representation. And that's something with the way they draw it. But if you look at what it did in VE, it made this terrible, ugly thing in the map. Well, a properly tuned VE table on your typical LS today looks like this. Your boosted LS. Its lower left-hand corner is low RPMs, low vacuum, which is your idle area. And up here in maximum torque RPM is where you find the most volumetric efficiency. Volumetric efficiency numbers are proportional to torque. So what you end up with, if you have a properly tuned VE curve, will look just like a wide open throttle pull or a sweep on an engine dyno, or even a chassis dyno under the right conditions. So you'll have your highest VE numbers at whatever RPM you make peak torque. Peak torque happens when you get the maximum amount of air into the combustion chamber and burn the right amount of fuel with it. You get the most force down on the pistons. That's peak torque. And you'll see that point. So if you have a rough idea, almost all engines make their peak torque somewhere 3/4 of the way on up from their usable RPM range, right? And you can usually find out with your engine combo, find out what those engines typically run at what RPMs, depending on the build quality. If it's a full-on race engine, they might add a couple thousand RPM or more to the upper limit. But long story short is you're going to end up with something that looks like a torque curve, and most engines have torque curves of similar shapes. Low RPM, low vacuum, or low pressure, high vacuum. Then where it's going to idle, where my green dot is here, that's typically low volumetric efficiency, low cylinder fill, because there's no load on the engine, but you're restricting it with the throttle. The throttle is, open 5%, 95% blocked. So it's drawing a vacuum and it's slowing the RPM down because there's only enough torque available from that airflow to spin the engine at that speed. That's why you adjust your idle speed on old school carburetors with just the throttle stop. That really controls the idle based on the amount of air that's getting into the engine that controls the idle speed. Anyway, I'm kind of bouncing all over here. The other neat things about volumetric efficiency, besides the fact that all engines have similar VE profiles, they all kind of look like this table here, is that RPM, cubic inches, injector size, etc., do not affect this table like they would if you were doing pounds per hour tables, right? So if we go back to this map on pounds per hour, you can see there's significant differences. But in an area that, like this area here, should all have about the same available torque, therefore the same airflow, regardless of the RPM factor. But you see the numbers range from 4.4 to 20.5. That's a pretty steep and weird. Just, it doesn't make sense to me because the engine hasn't. Why do the fuel demands dramatically change so much? Well, it's because the RPM went up, but this table doesn't factor in. These numbers don't factor in engine RPM. They're not letting the system do the math for them. You go to conversion here and look at this area here. They're all, 51 to 68% or 56 to 68%. So, I mean, it just makes a little more sense to me because you can tell when the engine's working harder, it's up in these areas up here. And when we're cruising down the highway, it's in these areas here, right? And then when we're at idle, it's somewhere over here. Things that changed. The other thing I wanted to add was examples of what different cams do. People ask, hey, what does this upgraded cam do? It gives me more horsepower in the top end. So it might, if you get yourself the, full pull performance cam for your LS, which hopefully you do, what you'll end up with, and this is with typical of Bewley's cams, what he's figured out is you'll end up with bigger numbers up here because in Holley's limited and not quite correct VE model, it's the entry level one that Brian talked about. These numbers are proportional to fuel flow and airflow. So with his cam flowing more air under boost and higher RPMs, these numbers will raise up here, and you'll have to smooth your table out some. Let's say it's not that much.
On boost, will you see that same reaction? You'll see skewed VE numbers up top in Holley?
Yes. Yeah.
Okay.
Just like the Megasport. So it still goes up above. It won't level off at a true 100% volume.
I boosted, about 1,000 crank horsepower boosted map here, where that's one thing I always like to point out. I kind of hinted on it, but boost does not increase VE. Like if you think of the equation, we take map into account. So you already have boost into account. Boost can increase VE because you've got pressure on one side and vacuum on the other.
Just slightly though, but what he's saying though, now just realize like with Holley, when the boost goes up, these VE numbers are going to go up. It's not a true representation of volumetric fill. That's
just because of the models, not
the model is oversimplified. All. The model is oversimplified, but don't let that scare you into thinking it won't work or can't be made to work. So let me show them real quick what a Bewley cam does. Just 1 second. Let me knock this out here real quick. So this spot up here, if you've got a cam that gives you more airflow up top, then it's a guarantee that it's sacrificing or taking away. So the difference from a less aggressive to a more aggressive cam is this area will have bigger numbers basically, and this area around idle will have smaller numbers. You end up with a 3D converted 3D that looks kind of stupid. So this is where you end up getting into your blending and playing around to get this map to look like something, normal again. So this is typically what I would be doing. You know what we ought to do is when the network's good, when I'm at the place that has the good network, the other house, we should do a real-time tune with an engine running with one of the listeners. Maybe we could have a drawing for that or something. But because I could do this real-time via any desk with a functional network, and actually we could watch the thing, how it improves or how it runs. But long story short, you end up with a more aggressive cam, you end up with a VE table that looks like this. So that's all. Sorry to interrupt. Now, Brian, if you want to carry on, if you want me to demonstrate something, I'll leave the screen up.
Hold on.
I was going to say, when you swap a cam out on a true VE model, it's kind of
Sorry
like
about that.
string.
My wife was headed to bed, so
No problem.
Yeah, I don't know where we left off, but I guess so. Yeah, looking at kind of now that we've gone through some VE stuff, back to seeing why that equation matters, and when we talk about, like Scott said, just because this isn't exactly right doesn't mean it doesn't work. It's still a better system. The thing to just keep in mind when you're tuning that is understand what the math is doing a little bit. And like I said, normally under an absolutely perfect modeled fuel VE system, typically once you get up into boost, once you get the basic bump from a little bit of pressure increasing your VE, typically VE will not increase with boost. And the map I'm looking at here of this drift car, we basically have the same VE more or less once we get to about 7 to 9 pounds, all the way up through where this engine was tuned at 15 pounds. I think we see a 1% increase in VE up top, which is just a little bit more efficient on the turbo, a little bit better efficiency. But yeah, you're a very, very, very small increase. So where Scott was showing up there, that the shape that he drew is going to be exactly what we were looking at on something like Haltech or Pro EFI or Mtron. And that's when we started talking about stuff like Mtron or any of this stuff that also does fuel mass flow stuff, where it's actually calculating intake valve temperature. And when you're down low, it's actually calculating how much fuel is evaporating. All the target of that is to make your map more consistent, so the engine runs more consistent regardless of what the conditions are outside. So that's really,
and it's worth doing,
basic.
Especially in an OEM consideration. It's really worth doing. For a standalone stuff, does your drift car or your, project LS swapped whatever running this need that even on Holly? No, man, you can make them run good, but you're going to rely a little more on corrections.
Yeah, I mean, it depends on what you're doing too. There's a lot of guys. If you're a budget guy, like my teams are one of the few ones. Ironically, the team I work for now, I'm not the one that tunes the cars, but I am there and I can make adjustments if we need to. Not every guy travels with their tuner or has their tuner as their crew chief. So some guys really are just, hey, yeah, let's load our car in, and wherever we go, it needs to be consistent. So yeah, it's again, if you're just doing drag race stuff and you're making an adjustment every hit. Maybe it's not the biggest thing in the world. But if you're not traveling with your tuner, you're not the guy tuning it, or you don't want to be messing with it, or it's, a street car that you've got to drive all over the place. That's where the consistency comes in. Road course stuff, especially, during some sessions, endurance especially, we'll see temperatures and conditions change so drastically, that it can make a huge difference beginning to end a race.
Sorry, our network's flaking out again. Getting messages, warning messages. Prepare for crap. So, all right.
YouTube still looks like it's gone.
Anybody asking questions, or is everybody gone because it dropped off? Everybody, they shouldn't dropped off this time, but it was dropping frames. That's doing it again right now.
Yeah.
Yep. Damn it. We're just gonna end up redoing this one. I can tell it.
Yeah.
That's enough.
Oh, okay. Well, practice run. We can polish it up.
We need to get our shit together.
Yeah, it's a lot better showing them the basics and then explaining the math behind why this works, rather than, hey, here's some math for people that have no idea what we're talking about.
Right. No, it's all right, because there's some that do. I saw a bunch of guys were commenting on the for a minute when our stuff went down. I got back on my phone and it started working again, and I saw some of the comments, but because of the network reduced bandwidth crap going on, I can't run any other devices to watch look at the questions. So I don't know if Bill or anybody else, you guys are able to see what people are asking, but I am not flying, and I am flying blind, and that is not a comforting thing. So carry on.
We're going to cover
the YouTube still looks like it's still going.
Okay.
Yeah,
Facebook dropped off.
It hiccupped there for a second, but yeah. So I think we talked about this a little bit last week, but V8 Billy asking, when using EGTs, what do you tune with? Fuel, timing, or both to achieve balanced temps? And I think, Scott, you and I think we're kind of on the same thing.
Yeah.
For the most part, a little bit of timing to get them balanced, right?
Yeah, I mean, in your typical domestic V8, that seems to be the place to be. I've seen some of the inline 4 and 6 cylinder import motors. Even you wouldn't think they would work well, but those typically don't need as much of a timing change as if it's an LS or a Coyote or a. And honestly, you want to first make sure that you had like a machinist install those probes in the same exact depth, the same distance from the flange, for the exhaust flange on the port on every single cylinder, because you got to make sure, you got to realize that 60 thousandths depth difference can be like 400 degrees at wide open throttle difference EGTs. So
that's
generally,
you guys do at homebrew systems.
I mean, generally, I have people keep it so safely rich and safe on timing that it doesn't matter if 1 or 2 cylinders are leaner than the rest because they're still all plenty fat. That's the easiest way to do it. The way I tell most people do it. The way 99.9% of racers. I don't think Stevie Fast spends a ton of time doing individual cylinder tweaks too much. They might look at plugs and move a couple degrees around hole to hole, but I don't think that's a giant priority for them, because they run big, fast motors and they detune them and they run them safe. But anyway, so I would then, what I love EGTs for, though, people know I love EGTs. They're kick ass for diagnostics. You would not believe how many engines are out there running around on 6 and 7 cylinders, and the owners don't even know. And they're missing like over 200 horsepower because they have 2 coil connectors from their crappy harness. Say what?
You guys saw the one of the Mustang we were trying to tune, and it freaking had melted plug number 1.
Yeah.
Because the guy drove 4 hours after he picked the car up. We tuned it. Everything was pretty good. It made a little less power than I expected the first time. And then he comes back complaining all these drivability stuff. And I was like, okay, I'll go for a ride. And literally, we didn't even make it to the parking lot. I told him to turn around and bring it back. Popping and just so bad that it had a bad cat, a brand new cat, Cook's cat,
and
that was put in.
Nice.
It basically,
sucks.
during his drive, the cat came loose. Like the substrate inside broke away. It was just a failure, and it turned and clogged the exhaust while he was driving. Well, he kept driving that way. So he's like, oh, yes. So he replaced the cat and all that, brought it back for a tune, and literally 2 pulls in. I'm like, all right, something's not right. And, the freaking cylinder 1, it's completely dead. Every now and then it'd make a little bit of spark, but completely dead, cold versus everything else. Just completely melted the strap off the plug because he not melted, but he was just sitting there, misfiring with crazy back pressure on that whole bank.
Yeah, no, that's a common deal with an ignition problem. The EGTs are super nice because it would show you which hole it was right away. Hey, man, number 3 is totally colder than the rest of them. The other 7 are all within 200 degrees of each other at any given time, but why is this one completely cold? Oh, shit, I didn't realize. I forgot to plug the injector in.
So there are some what I would call analog ways to check this stuff.
Sure.
The middle distance one is if you have one of those infrared heat guns and you can just run it across the top of the tubes, to see how they're running. Are they even or not?
If you're using headers,
the most analog, if you have headers, even if you have an exhaust manifold, if you just dribble water on the top of each manifold where it hits the head, you can see how fast the water burns off. And if it just sort of sits there, you got a dead hole relative to the other ones where it just turns to steam instantly. And I realize this sounds old tech, but not everybody has EGTs. Not everybody even has a working heat gun. But there are ways to know whether stuff is hot or cold, which is
everybody
what we're
has
talking
an
about
unused matchbook they can set their points with. Sorry.
Yeah.
Lick your finger and touch the header tube.
Thank you, Billy. I was waiting for somebody to say something. Yeah. It didn't melt this finger so quick.
You guys can make fun, but, that's how we had to do stuff back in the day, you little whippersnappers.
Right, sons of bitches. Right. So anyway.
Or the all tried and true, if I think I have a dead hole, I pull the plug wires off one by one and see which one doesn't change RPM. I mean, there are a lot of
just make sure you do it with the engine running.
I did that.
Oh, yeah, because then it's more fun.
They used to do that.
We do that
they called a cylinder
figure out
balance.
if we've got a dead injector wiring.
Yeah, I mean, it's sad if you have to wait until you open up the engine and realize that piston's completely clean compared to the other 7 or whatever.
Sucks.
To find that out. So that's the point, is that those there are other ways to deduce these things.
Sure. But EGTs are a damn nice way of finding it quick when you got a lot of other tasks on the car and you want to race it and get it ready. I love the EGTs, man.
EGTs are a mixed one for me because they're good and they're really good for that. But a lot of guys get so hard up on, oh, this ECU has X EGT drivers, and I absolutely need those. And
really?
I don't know, like
I don't get. That's not one of the snot. So the drag racing guys don't argue over that kind of thing. That's cool. I'm glad we don't have to deal with that.
Yeah. The import. A lot of the import
it's
guys,
11 degrees off.
It's back to the whole, the same guys that are so paranoid about not having knock sensors. And, I just went through that with a customer who's insisting on wants a budget ECU. And then he's like, oh, it's got to have knock. It's got to have knock. And I'm like, why? You're not, this is going on a performance application. So
we're totally going to not tune it to knock. But
I'm trying to find
anyways,
out
anybody else asking questions? I wish I had a demonstration to give here at Holly with a real engine because I'm realizing now real time would be fun because we could see it, obviously watch it run better and be a little bit snappier real time. But so that's all I have for that.
Sure. We got V6 Billy again asking basically what's the okay deviation during a run on EGTs? 200 degrees, is that called good or something like that?
Depends what kind of numbers you're seeing. I mean, some of my Bonneville guys that are measuring, right at the port are on gasoline are over 2,000 degrees for a little while, for maybe 10 seconds of their run or 15 seconds. But again, that number changes when we change the depth. So we have a guy with basically super accurate with those EGTs. And even then you hope that everything is scaled properly. Generally you see them when you key it on and the car's been sitting overnight and they all read 74 degrees or whatever the shop temperature is. And they seem like they're all pretty well in range. It's not common to run into K-type thermocouples that are way off. They pretty much have the science figured out on making those things. At least on the not super cheap Chinese ones that are like $8 or whatever, but you spend $35 on it for a thermocouple and you'll get something decent.
We mentioned it a little bit last week too, but just temperature probes in general. When you start your engine up, if you have a 30-degree difference after your engine's been sitting for 2 days between your oil temp and your intake temp and your coolant temp, especially your coolant and oil temp, go back and visit either your sensor or your sensor calibration. I had a guy panicking that his engine was just running hot all the time until he let his car sit for 3 days. He calls me. He's like, hey, I started my car. And my oil temps, which is the sensor I sent him, the motorsports level sensor, said it was one temperature. He's like, yeah, my coolant temp says it's 30 degrees higher. And I was like,
did he have a GM calibration in there for it?
His sensor with the exact same sensor. Yeah, so he had he was like, hey, where'd you get your coolant temp sensor? He's like, oh, I got it from Amazon. This is a generic GM Amazon sensor. We put, one of the AEM Haltech that everyone that uses the 1/8 inch MPT Deutsch connector style sensor, and magically his car stopped overheating because it was a phantom issue. He's, adding a bunch of fuel all the time that it didn't need because it wasn't actually that hot, so the intake valve temps weren't that hot.
This is when it's also interesting to know if you have a bad sensor, what does your system default to? So, for example, on the Mega Squirt that I've run for years on the Drag Week car, if the IAT is not connected, it defaults to -40 as the IAT. Which
GMs are the same.
Fatter it's a GM sensor. So, that's what that does. So it's important to understand the characteristics of your sensors. And even before you light the engine off, when I turn my stuff on, I look across all the things because when everything is ambient, everything is ambient.
That's what you need to do. Make sure all the sensors make sense, pressure and temperatures.
Yeah, the oil, the coolant, the air temp, everything is going to be the same. And if they're not all reading the same, then you already know you have a problem and you haven't even lit it off yet. So there's a lot of what I would call common sense stuff out there as people make these conversions to understand what those things should look like. It's also why monitoring your stuff when it's running, you can do that with data logs or having actual gauges, pardon my French.
Sure.
So you have a good sense of what things look like. So for me, with a car that I drive, I have two AFR sensor gauges, Innovate MTXs. So I'm really familiar with what those AFR readings look like bank to bank.
Yeah.
And if I start seeing something weird, I know that something has changed, and now I can start working through what changed to cause that, without just assuming, oh, the gauge is bad, oh, the sensor is bad. And it's usually something, well, stupider, like we somehow forgot to reconnect a injector on one bank, or you know those kind of things. So it's good to understand what everything should look like and get acquainted with it before chasing down ghosts.
In the systems that let you set your default, your failure mode too, most standalones will let you set what your sensor will read when it fails. That's something to keep in mind, that, hey, can I set this in a way where I can still limp this car home? That, yes, I know there's a problem, but the car doesn't just die. You know, a lot of cars, a GM, if the IAT dies and it starts reading -40, they tend to run like crap. If it's
because it'll dump a ton of fuel in thinking it's -40. Yeah.
Exactly. So thinking about that and what keeps you safe and lets you, in some cases, you know, in some of the drift cars or in endurance cars especially, you know, we'll say, hey, throw an error, do some stuff, but make this your default setting.
Yeah,
so maybe we can actually finish the race. And we at least gives us time to make a call of, hey, is the engine going to run safe enough? Can we finish the race? Or, you know, do we need to retire the car?
Well, it's also smart too. Some guys don't have fancy standalones and all this that are fully programmable. So, you know, your OEM GM stuff, for instance, does default to -38, -40, you know, depending on model. You know, if that sensor does fail, you know, especially on something like a blower car or turbo car where, you know, the thing could potentially be super hot, you know, luckily it's going to naturally enrich the fuel if it's in speed density. If it's not in speed density and it's running on the mass air, it's going to do nothing for the fuel.
Yeah, which is nice about mass air.
Yeah, which is no good. But you can go into your, you know, intake air temp, timing tables and stuff like that to yank a couple degrees or something out of those temperatures that it fails to, just as a fail-safe precaution to kind of detune the motor while it's in that, you know, quote-unquote limp phase where one of the sensors is bad.
Yeah, and that's where going back to understanding how these sensors are playing into the calculation and the equation, that's been a huge thing for me. Once I kind of understood that equation, it just made a huge difference in my ability to troubleshoot. And, you know, when I would say the tuning part is easy. Hitting the keyboard, making air fuels right that's freaking easy. Making an engine not knock even. The hard part is when you do all that and then the engine does something you absolutely didn't expect, and then figuring out why. And it's usually because either some piece of data was wrong. Yeah, exactly. Or
that's where the YouTube guys start making phone calls. Hey man, it's out here.
So there's two questions that Ron Wright posted on YouTube that, you know, kind of take this to the next level. One is, can you take a good pound per hour tune and convert it to VE with Holly?
Someone want to send me their pound per hour tune anonymously? Let me go find I think should be able to grab the Holly ones in here. Talk amongst yourselves for 30 seconds.
So there are some ways, you know, Holly has some ways to do it in some of this software. If you go back to the math table and you understand it the other way, what I used to have to do back in the day before we had a bunch of these really fancy VE stuff, I would actually do, I did this on a Formula SE car back in the day when, you know, our ECU didn't do VE properly. I knew what the VE table should be because I knew what the torque curve should be, and we had a restrictor, so I could actually calculate where we would be choked flow everywhere. So I wrote, you know, an actual airflow Excel spreadsheet that calculated airflow and what I expected, and then did the backwards calculation of that. Is I took it, I knew what my VE was, I knew what air fuel ratios I wanted, and I knew what size injectors I was running. So from there, I could calculate what the ECU would do and calculate what my injector pulse width needed to be, uploaded that. And I was doing that because I couldn't be at the dyno when they started. So we had a kid that was learning to tune at the time. I was like, hey, just get it on the dyno and do this.
Okay.
And I made it there a little bit earlier, was there 20 minutes after they started. And as soon as I show up, kid does a wide open throttle pull. And I'm freaking out. I was like, dude, like,
Stop.
I thought, like, I told you to wait until you're ready. And he looks at me and his first words is, I hate you. I'm like, what do you mean? He's like, I literally deleted the map on the car at 2 a.m. the night before and uploaded this one that I made with map. And he was like, your map was within 5%, 5 to 10% everywhere. And I'm like, it's math. That's all it is.
That sucks though. Troy, I can answer that guy's question. I got our screen up now. So here's I loaded up a tune that was a Holley default tune under what? Custom? Hold on, ABC. It's in backwards alphabetical order. Custom cows, General Motors, LS. I got the 383 to 430 cubic inch turbocharged 30 psi on gasoline map. Okay, here's pounds per hour, the 3D representation. Okay, I guess that's what pounds per hour should sort of look like, but I really know what VE should look like. These should have my highest numbers at peak torque. So switch. Let's take a look first at their fuel graph here. Yeah, I mean, the actual spreadsheet version, the cells. I mean, that would make sense to me. That kind of looks right. I was looking at the heat map or the colors, I guess. But once you put this thing over into VE mode, go back to the graph, and you remember what the good one looked like a minute ago. This came out as a recommended tune for a factory application. So the guys on the podcast here with me, they don't see my screen, but the rest of the world does. But you watch in about 10 seconds when it pops up for them, and they're watching it on the stream.
I'm doing split screen, so I'm seeing both.
Okay. Do you see the VE table that I'm displaying to the rest of the world?
Yep.
Yeah. So that's that's totally not right. I mean, it needs to look like.
Oh my God.
Yeah, I mean, it needs to look like this right here. This is what the VE tables look like in OEM applications. This is what it looks like if it's in Megasquirt, if it's in Haltech, if it's in Pro EFI, if it's in Motec. All those that tune in VE mode, they all look like these. So you can put a table in that's shaped like this and just raise and lower the whole thing, and usually it'll start and run, and you can start tuning and be within 20% either way. But yeah, if you look at the one that comes that they thought was tuned in pounds per hour mode, that was done well enough to be representative of a, that you're supposed to be able to plunk in your engine that meets those criteria. We can make it small table and graph it this way. And once you convert it to 3D, the volumetric efficiency, you end up with this stuff, which no engine's going to run smooth on that. It's going deceleration is going to be weird. It's part throttle cruising. There might be some spots where it's great and others where it's just fouling plugs. I don't really know. So the long story short, we'll do a webinar. I've got some webinars about building a VE table. I've got a Holley startup webinar that's at RealTuners.com in the store. I guess a shameless plug right there, but go check it out. I show you how to build one of these the right way so that your VE table. It's funny. People say, "Oh, well, is that artistic and lame to make them super smoothed out and perfect like that?" If it's a street car that's going to be driven around a lot, then I think it needs to look. You need to make sure that your VE table is looking, somewhat shaped like this.
Yeah, I mean, if you're going to think about the way your engine's going to run, you're never going to double airflow in 50 RPM.
Yeah, exactly. So, it's all smooth transitions, right? So anyway.
That's right. I think a lot of people get caught up in, when you're talking about converting this, and people will it's got to be perfect. Honestly, I think Perdito mentioned it before we even started, is that VE is VE. You can take a VE table from almost anything and plunk it in, and it might not run great. If your VE is off, a lot of times I'll just start with a generic curve VE table, and yeah, it might be off 20-30%. Kind of get close, make some blanket changes, and you can start seeing where it needs to be, and what the shape is going to look like, and roughing it in from there. And don't be afraid to make big changes when you start. People get so caught up in it. If it's not really close, I need all these cells right, and how do I tune every single cell? Rough the shape in. It's gonna need to be a smooth map. You'll get an idea of what shape it's gonna be. And
a lot of people don't realize that pretty much any modern day standalone ECU has got a wideband that's closed loop controlled on the fueling. So literally on a Holley, you can be within 100% of what it needs to be in that cell, because by default the dang thing corrects plus or minus 100%.
Right.
Yeah, I can.
So-
They rely a lot on good correction. Holly especially.
Have a closed loop. Let me see if I have one. Because now, there's two sides to that, right? You don't want to just leave that on and be like, oh, well, it'll fix plus or minus 100%. And then you wind up with, a correction table that looks like a roller coaster.
Won't you also end up with, if you're running something that gains RPM very quickly, you're going to end up with something that lags. So by the time it leaned out and went to detonation, anything that it changed is too late.
It depends on the setup, but yeah, I mean that's where obviously your VE map needs to, by the time you're done, needs to be as close as possible. You want as minimal changes in your closed loop as possible. But a lot of times in something that's really off, if it's a remote tune and someone that's asking for some basic stuff, we'll get the car running okay. I'm like, hey, go just get it in these areas, and I'll see if pick a zone. Your idle low RPM zone, your cruise zone. If I see that the closed loop is pulling 30-40%, that I know that every cell around that too is going to be the same. So you can see a trend. And I don't know if Holly lets you do that. A lot of software will let you filter by the number of hits a particular site has. So in Haltech, for example, where it does long-term correction, where it'll learn over time what it is, you can actually set up that threshold that it needs to see that correction so many times.
There goes our network.
Yeah, I was
wondering what happened.
Oh, it came back. It came back. Hey.
Yay.
Okay. Recovery. Sorry, guys. So we've dropped 6% of our frames this evening. That sucks. So that's a bad number. But anyway, carry on.
I'm not clear who's here to carry on at the moment.
Who else did we
it's sort of
lose?
dropping
James is
out.
back. I got James. James on video. Right on.
on video, no less.
Well, it popped up. Ask us.
I did that
to start
twice.
video. I was like, whatever.
Yeah. And then I did it again. I was like, bing, send video. No, cool. So anyway.
So we kind of touched on Ron Wright's question about good pound per hour tune and convert it to live VE to VE with Holly, and you volunteered to take a look at that offline as well. He asked a secondary question, different end of this, any tips or tricks for finding RFI that causes issues with Holly or other than using an old school AM radio? Hello.
I didn't hear all that. Go ahead, Brian.
Honestly, well, I mean, my thing was going to be build a good harness that doesn't have an issue with noise. I don't have
Upper grounds.
but yeah. I mean, the first thing is really have a harness that's, any magnetic signals, especially that are shielded, knock signals that are shielded, using shielding and good grounds to prevent that in the first place. As far as finding it, I don't really have a good trick. I don't know if anybody else
I was going to say, my trick for doing that is keep noisy stuff away from signals.
Yeah, I mean,
I don't know that I've seen something where you can plug something in to diagnose where the problem is coming from.
I mean, depending on what it is, normally if you're worrying about noise, it's going to be on a trigger or something like that, I'm assuming. In which case, my go-to is grab a scope, and that'll tell you right away what you're getting for a signal. That's not everyone has access to a scope, and unfortunately, not every ECU has a built-in scope. They're getting more and more that way, but I haven't yelled at Haltech for a long time because they claim it's coming, but I've heard that, so it's probably about time to yell at them and make sure that it is coming. But even on that, though, there's a lot of ECUs that have scopes that aren't a real scope. All they're showing you is a trace of when it sees a trigger or when it doesn't. I think Megasquirt is that way, right? It doesn't actually show you a trace of the signal. It just shows you when it sees a trigger or when it doesn't. So if you see a false trigger, it'll show up, but it doesn't actually show you the shape of the noise. So, if you say, like on a Hall sensor, which, we typically talk about being less susceptible to noise, and they are. So, not everyone shields them.
Yeah,
but they
less
still
susceptible
can
to
make
radiated
noise.
noise. Yeah.
Right. And typically on a haul, you can get noise causing an issue. And one way to find that is typically noise on a haul signal will be sinusoidal. So it'll be, like a magnetic or a VR type signal, whereas the hall sensor will be square wave. So if you're getting any kind of sinusoidal pickup on your hall trigger, you know that that's noise. It tends to be easier to filter out, AC or DC coupling, or just a lot of times it doesn't cause an issue. But there's a lot of stuff that the real basic scopes, like the Mega Squirt scope and the ECU Master basic scope, miss, because they're just basic trigger scopes, and that mode's nice because not everyone is going to look at a raw trace from a sensor and say, oh, this is what's happening. They just want to say, oh, I got 12 teeth. That's cool. But that's the best way, in my opinion.
Is prevent the problem in the first place.
Well, I prevent the problem if you do use a scope.
Scott,
I've actually
you had a low cost kind of oscilloscope solution.
I'm the king of cheap scopes, man, because you don't really need a fast one. You don't need one with a lot of sample rate. You don't need a lot of resolution. You need something real basic for automotive applications. And
using a Pico scope.
Yeah, I mean, I guess what I really like recently is now for $125 you can get a legit Pico, Pico, a Pico brand 2-channel USB bus powered scope that you can literally put with either a full on Windows tablet or a small laptop, with anything with a USB port and the ability to run the drivers for the scope. But you get the benefit of Pico's house software, that if you've used any of their more expensive automotive diagnostic kits, they have 4-channel scopes. Oh, neat kits that come with all kinds of different probes and inductive pickups and things like that.
Another company, it was a DSO Nano or something like that. The Nano scope.
So I've got a DSO Nano and a DSO Quad for the ultimate cheap. The thing I didn't like about those is you got to learn how to use the menus, but there are some good tutorials out there. If you guys know Andy Cook at Motion Raceworks, he mastered the DSO Nano and Quad, and it was pretty cool because I wasn't as good at using them, but we needed one bad working on a car of theirs at their shop, and he pulled it out and he knew how to run that thing, and that little thing was damn handy. So we figured out all kinds of challenges.
Yeah.
What's that?
It's probably not as big a deal, but I run into the problem a lot with working with technicians or guys like that who they're not tuning guys. They don't want to touch a laptop, and guys that are just afraid of it, that they're like, oh man, is there anything that works on my phone or whatever? And that's where that's nice for them, is like, hey, look at this screen. Just, this will tell you.
Yeah, it's pretty basic, right? Right. No, but I like the Nanos and Quads. I can stumble through one of them, but I always have to fire up a YouTube tutorial and navigate in the menus. But man, the Pico scope, I really like their laptop software. If you don't like to fumble with a laptop, then beyond that, in the low to mid $300 range US, you can get like some benchtop Chinese type scopes that are pretty good. Just read the reviews on them. Make sure you're getting what you're reading the review about.
There's stuff coming out with cheap signal generators too, if you want to go back the other way and stimulate your ECU or something like that to see what's actually
I've always used the Gym Stim for doing that. Yeah, if you want to simulate an actual engine and run the ECU, make it fire the injectors and the coils, it thinks it's running an engine right there on your desktop. That's a Mega Squirt Gym Stim is super good for that, and for like $80 or whatever they cost assembled, they're worth every penny. But
so along those lines, since so many people are doing relatively late model swaps, one of the things that we stumbled into is Coyote swap. I'm going to turn it back to that. Yes, I am.
No, keep it up, Bill, because you've moved from big block floored to Coyote now. You don't have to be as embarrassed anymore. They're actually popular. Go ahead.
Oh, thank you. I'm glad I don't have to be embarrassed.
Sorry.
I went from, too big to fail or too big to win to more chains and brains. So whatever.
It's okay.
One of the interesting things, because of the carb legal aspect, is we're running the fuel pump driver module from the 2018, which means we had to put that into the back of the 99 car and run the wiring to it and all that. One of the interesting things about that module is it is completely wrapped in heavy foil covering and has that foil grounded when you mount it to the chassis of the car. And I found that was interesting because that's in essence, as I understand it, a PCM module. And they thought it was worthwhile to actually shield that thing with grounded shields, even though it sits in the trunk. So it's not necessarily interfering with much of anything else except maybe making noise on the stereo. But I was just kind of curious to get you guys' opinion on why that happens with a fuel control module. And I know guys doing LS swaps are dealing with the same stuff when they pull more recent stuff to put in older cars.
I think a lot of it is just it's running with high power wires, right?
Yeah, moderately.
Or is it running?
Yeah, I mean, it does have higher power wires, and it is not, big, huge, thick stuff. But it is doing that, and it is modulating. It is managing, because it's a returnless system. It's managing voltage and frequency of. I guess it's doing that too to the pump as a way to keep the pump supplying all the fuel the engine needs and no more, because it's a returnless.
Yeah, my guess is they're being a little more concerned on the noise on the frequency. And so like anything, I guess there's two sides of it. So anything that's I don't want to say high power, but higher power, boost solenoids don't tend to pull that much amperage. But anything, so flex fuel sensors, Hall sensors, stuff like that, it's actually because they're sort of a higher power frequency switching sensor. They can cause noise. I know that's one thing Nick at Mtron is really sensitive about. And that's one thing where he'll say that if you ground a Hall effect sensor, any high frequency sensor, an idle valve, a crank sensor, a cam sensor, a flex fuel sensor, anything like that, to the sensor ground on an Mtron, and he sees that in your wiring schedule, he will have a hissy fit. I mean, temper tantrum hissy fit. Because, and he's not wrong. From a actual technical standpoint, there's basically you're pulsing this ground on and off, and it can cause a lot of noise, and then can backfeed through either the signal or the frequency control or something like that. My guess would be because it's running with all that far on the chassis next to God knows what, if it's running next to speaker wires or whatever. They're just worried about noise coming through on that signal, causing inconsistent fuel pressure control or fuel flow control and fuel pressure.
That makes sense. There's another question that popped up from All Wired Inc. Says, how do you guys calibrate the airflow map when using a progressive throttle body, period? I think the map is located in the Excel enrichment section, period, Holly HP.
Yep, I can actually show him that. Hold on a sec. I mean, carry on, but I can show you that map that he's talking about.
As someone with a Stone Age big block that had 4,400 CFM of double progressive four-barrel throttle body.
Over 1,000 horsepower on the engine dyno on crappy California pump gas. I couldn't believe it didn't kill itself, but it did it reliably.
Yes, theoretically there's a little bit of change there, but if you're running on, and Holly's probably going to be a little bit different there, if you're running on a system with a true VE map and you're getting a consistent map signal, that's the thing to say here. That's where, if we want to get really into it, where ITBs and some of that stuff causes some issues where your manifold pressure goes to atmospheric so quickly. Theoretically, if your VE map is correct, it should be close. But I guess I think we're about to lose no, we're good. I thought we were going to lose the stream there.
Is it still there? It's dropped a little frames when it came back.
Yeah. You might change V a little bit because you are restricting it a little bit more. So if you get, throttle positions where map changes very quickly, that's where you're going to have the problem. Is that what the map you were going to show is, Scott?
Yeah, I wanted to show them the map for hang on, it's coming in 3.
Sort of like a blended.
What was the table that Bill? Go back to the question. Was it the acceleration enrichment correction?
I think the map is located in the Excel enrichment section.
So is he talking about per temperature? Read his question again to me, please. I'm pretty sure I got it.
Said, how do you guys calibrate the airflow map when using a progressive throttle body? So obviously
usually
that's not a single blade anything.
This table right here is what he was talking about. It's under AE correction versus throttle position. In other words, if you've got a throttle let's not call it progressive. Let's just say like all modern, especially monoblade throttle bodies with a single blade, where you open them up. By the time that at idle, if they're 35 or 40% open, that's actually wide open throttle. The throttle only has effect based on if it can fill the intake manifold with the atmospheric pressure. This is before you're in boost, but basically once that throttle is open a certain amount, it has no more effect. The difference between 50% and 100% on most single blade throttle bodies nowadays that are generally very large in size, it does nothing, actually does not to impede airflow until you're really looking at a lot of boost, a lot of velocity, a lot of mass. So what this table does for you is that you kind of compensate for that, because if you're whacking the throttle starting from idle at 0 or 1% throttle, and you stab the throttle, you're going to need a lot more fuel squirt in that first 20 or 30% opening than you're going to need in the next 60%. That's what this table does here. It's a multiplier of the Excel pounds per hour, of the total pounds per hour between MAP and AE, the actual accelerator pump. This is a more typical MAP for me. I do not use MAP. I just use TPS, but this table still applies right here. The AE correction versus throttle position. That's what he's talking about. That's how I usually use their default calibration, because it's really good for single blade type stuff. But in some cases, you might flatten it out and start from scratch. You can put this flat if you want, and this table is just going to change a little bit. It's going to look a little different. But basically, I still sit there and whack the throttle in neutral, and I watch for a little bit of black haze and then back it off and find it where the most crisp or quick RPM acceleration happens. That's how I tune them. That should cover him.
This discussion about single blades, especially oval blades versus round.
Yeah.
So from a drivability standpoint, I've been coached that 2 larger rounds are going to be better for drivability than a big single, oval blade. For example, on this new blown Coyote we're going to be doing, but even on the 600 cubic inch big block, one of the reasons it has 2 4-barrel throttle bodies as opposed to, say, 2 Ron's Flying Toilets or something, which would be 2 big singles, is to have drivability, because that's the reality of a drag week car. Is you want to be able to drive it and be able to drive around and have part throttle and all that stuff actually function, and that's progressive. So on that linkage, I drive off the very front 2 butterflies, then the back 2 butterflies, then it begins to bring in the other 4. So there is a great deal of progressivity built into that whole system, which you would not have with 2 toilets, for example, even though I know you guys found on the Engine Masters cars that 2 flying toilets was better for a watt pull, even at a wide range like 3,500 to 65 or whatever you guys were doing. So it's horses for courses when you're trying to figure out what throttle body and how to tune for it. What do you want to do, and what are you trying to do? If it's just max watt horsepower, fine. But for something you got to drive, different story.
Right on. Any other questions coming in? I apologize for not being able to see them tonight, guys, but the internet connection here has been it's dropping packets. I'm sorry for this. Cannot be a great stream. We'll have to reload the recordings I've made here and edit them and to get the crap out of them. But
I think we only got
my
like
Facebook completely
live.
flagged.
Yeah, Facebook's down. I think we've only got 21 people. So maybe a redo, polished.
Yeah,
up
we
version.
can do a redo for sure. We'll put together a better program. But any other questions? We'll knock them out. Otherwise, we'll get off a little early. And we're losing, how many frames have we lost? 1,850. That's a lot for the evening, considering I'm doing only 10 frames a second.
It is interesting to me to note that Ring Central now has a little tag that says it's powered by Zoom.
Yes.
And can't help but notice from watching the news and everything else, I'm chiding my former Cisco buddies mercilessly about this because it's like, where the hell is WebEx in this? But the bottom line is Zoom is everywhere, even though before COVID-19, they were worried about Zoom users' viability. Yeah. Well, there was a point where there was a question about its viability, and now suddenly it's, every hell, the local channel 7 was Zoom 101 today for people that I'm not sure know how to spell Zoom. So it was interesting. And now I mentioned all this because Ring Central now says powered by Zoom. So it'll be interesting to their stuff almost be on AMS or something or AWS because it's proving to be pretty robust in the clutch.
Yeah, I think so. I mean, right now, I know the problems we're having tonight are not Zoom. The problems we're having tonight are my local carrier, which I always, when I'm at this particular location, I do it over a cell phone line and usually have no problems 99% of the time. If we do have a problem, it's not a network thing. It's me being stupid. But yeah. But anyway, so Zoom and we've been using Ring Central, but it's been Zoom at the core for quite a while, like 2 years now, I think. So year and a half, something like that. I
remember seeing the powered by before. Maybe I just missed it.
Right. Now that little icon's been there for a while.
No other questions have been posted, guys. So
okay.
This looks like a good time.
Bewley, are you still awake?
Okay. Bewley's gone.
He fell asleep. We lost him.
Yeah.
Perduto was looking at us, and he closed his garage doors, so he must be getting ready to can it.
Yeah.
No, it's starting to get a little chilly. I got a little chilly.
Oh no, it's 75 degrees.
He's in Florida.
No.
It's like
You're
68.
pussy.
Okay?
What?
Oh my god! I would kill for 68 right now.
I know,
hey,
right?
Is that a Buick convertible sitting?
That is a 63 Wildcat convertible. Yes, sir.
No, why? That's
turn
nice.
the camera, dipshit. We want to see. There we go. Hold on.
Yeah, talk some more. So
tell us about this car, dude.
That was my grandfather's. It was anytime someone dies, there's family politics involved, and it's been mothballed. I've had it for probably about 7 or 8 years, sitting in the back of the shop, covered with all kinds of crap. And with us getting kicked out of the shop here recently, it was me and Amanda looked at each other and were like, you know what, it's time to make the old girl do something again. So that's my project now until the Christmas time. I told Grandma that this Christmas we'd be able to drive around and go look at the Christmas lights. So
Badass. What motor was in that?
Pretty much get that insulation off the top.
Yeah,
it's light.
It had a 401 nail head in it, but it has since gone the wayside. I had a cracked block and a cracked cylinder head, so they're done. 401 nail head to Dynaflow with a variable stall torque converter thing.
Do you want a replacement 401? You're not going to believe this, but I know somebody who has one completely rebuilt, brand new, ready to go.
No, because I already gave the Dynaflow to a buddy, and I don't want to put that whole setup back together.
I don't blame you. But if you LS swap it, I will slap you.
That's what's right there.
Oh, no!
No. Wah, wah, wah. No, actually, that car will be badass with an LS swap. The purists are going to kind it.
Knock sensors. I don't know if you saw while Brian was talking about knock sensors. I actually grabbed the knock sensor out of the motor of the trash can and popped them in.
I saw you throwing shit in the trash. I just didn't know what that was.
Oh man, a 455 with a 4L80. That's what it needs.
Yeah, I was telling you guys, some of the guys here freak out about, and that's honestly, I'm going to blame Nick at Mtron about that too, because everything he tuned has to be 100% everything. Like, some of his shit is crazy, and like I get it, but like he's taught them that everything needs knock sensors. If it's not knock sensors, we can't tune every cylinder perfect and know when everything's misfiring. And I bring my car in, they're like, oh, you got knock on this? I'm like, dude, you
can make it perfect for that day on that dyno.
Yeah.
You know what I mean? But you can't.
My car's a GTO ECU with a 5.3 with different heads and a friggin' turbo strap to it. There's nothing correct about those knock sensors.
No,
right.
not at all.
Yeah.
Hey, Scott, there were two questions that showed up late.
Fire
one
away.
is any plans on doing a webinar covering data logs, which I think would be a great idea.
Ooh, that's a killer idea.
Yeah.
Okay, let's do our first webinar on data logs. Let's do that in the next week. I'll get something together on that. I was going through the old webinars. We need to do some updates using data logs. What particular system? Ask that guy to respond. What's he want to do it on? Megalog Viewer or Holly?
Well, I'm pretty much guessing it's Holly because his other question was Holly related.
Got it. Okay. Anything else?
And then V8 Billy 66 asked, what would cause Holly Dominator to go rich and stall engine after cruising and then no load clutch in?
A pounds per hour tune, crappy tuning.
Put the clutch in.
Yeah.
Crappy tuning.
Crappy
there's a good
tuning.
answer. All right.
I mean, seriously,
I was gonna
not good tuning.
Would that
if you're
be the after a throttle closed enrichment? No, just kidding.
They have that decel cutoff. It's pretty
everywhere
simplified.
where Scott was showing.
On the Ollie, if it starts going into closed loop like at idle, where it'll almost bounce back and forth from the VE table
Yes.
to the closed loop for the commanded air, and it'll surge, die.
Yeah,
And
I see a lot of them do that where they have the closed loop running at idle and say it was having to make like a 15% change, and you move the throttle and all of a sudden the closed loop correction turns off. Now the thing has 15% too rich or 15% too lean. Take a look at what your closed loop is doing around idle. You want to have your table sorted out just off of idle so that it doesn't need much closed loop, if at all. And I don't even run closed loop at idle. I wait till 13 or 1500 RPM.
Going back to last week, ignore your your wideband at idle.
Yes.
Give it what it wants. So if you're running closed loop at idle, then you're letting it correct for shit that could be wrong.
OEM guy just said that. That's awesome. I'm glad to hear you saying that, because it's easier to do it by feel on these applications. I've seldom run into an application where I need to do anything other than what felt right off of idle, and what pulled most vacuum.
Zero closed loop because all it did was fight me on a bunch of shit.
I idle.
Yeah.
Sitting there idling. By what the motor wants, not what the gauges tell you it wants.
Right.
Yeah, even if it's a little lean, you're not going to hurt the engine at idle. If you did, you had to ignore a lot of shit before you hurt that engine.
Well, you have to also realize that, O2 sensors, there could be literally a little pinhole in the exhaust, and it will completely throw that wideband off. Especially if it's got a bigger cam or something in it, it's going to have a lot of overlap anyway, so...
Yeah, exactly. Yeah. If you look back at what Scott was showing on those VE tables, I mean, I'll look at one here of this boosted LS down at idle is 40-49% VE, somewhere in that range. And if you think about it, that's at low RPM. So do that out into that mass airflow. That's not a lot of air. So a tiny leak could be as much as a 20-30% change in the measured air.
Right.
Or even just a little bit of overlap and a little bit of a blow through, basically. Which, if you want to get real crazy and you start digging into like the EcoBoost stuff, I don't know if the Coyote does this too, but all the EcoBoost actually calculates blow through under boost and corrects in their calculations for it.
Too much math, too complicated.
Yeah, dude.
I know some guys cussing some stock Coyote today.
If someone wants to have their head explode for a second, I can pull open an EcoBoost map and explain how that.
Fire away if you want to. I mean, we got a couple minutes to kill.
Why I refuse to tune the one that's in the shop right now. It's just I think
it's all the new stuff now. It's getting ridiculous.
Yeah, it's this is a good to talk about. When guys are so like, oh, you can tune your stock ECU. Why would you ever put a standalone in it? Stock ECUs are great for stock engines. Let me see if I can get VCM editor going here and open this map.
It's funny. It's funny you mentioned this, Brian. Literally, I bought this new truck 3 days ago. I read out the file with HP tuners. I looked at it. I said, no, thanks. I PM James. I'm like, hey, man, can you I know you like this stuff. Like, can you do something with this? Because there's way too much going on over here.
The GM stuff isn't too bad. It's the Ford stuff gets insane. All right, let me get over here and
all those cams and turbos.
Yeah.
Why am I not getting my? There we go. Share screen. Yeah. So the EcoBoost stuff from an engineering standpoint, I find this really cool. From someone that was asked if I was comfortable tuning this, having never tuned one before, and knowing that they had another guy lined up to tune one through a Cobb access port, I politely declined because I had so much other work to do that I was like, the amount of time it'll take me. This is your speed density map on an EcoBoost. So basically what's going on here is you have basically they're calculating in your trapped max air charge, so your max VE, what's possible, and these mapped points are at all your your different cam positions. Then with an optimum power, which is the optimum slope through everything, and the optimum cam
pull up
position.
one of those tables.
So the tables look real weird like this. They're just basically an engine RPM. This is basically the trapped air mass at a specific RPM versus RPM at a very specific cam position. So what they'll do is they'll go through and they'll lock the engine at this cam position, and they'll tune the engine in every single cam position.
Yep. Or every RPM. Every RPM.
Right. Every RPM.
Yeah.
You know, when you have a dyno cell with 500 gallons of water and how many ever gallons of oil, you can sit there and run these things forever. So what they've done here is all of these maps here are just for calculating maximum air charge versus actual load and then the offset. And then these two terms here in the blow through is there's actually a patent Fort has about this, which if you want to learn how to tune these, it might help, or you might read it and say, that's really cool, I don't want to tune this crap. They actually found that blow through, and they're basically having an effect on skewing your air fuel readings and as well as the actual air charge. Below a certain RPM, which is basically your map versus EMAP, it's quadratic. Above that, it's linear. So they actually have these quadratic calculations that calculates using basically calculus what the blow through is below a certain point, and then the switch over it becomes linear, and then it's just a basic slope. And this is just your speed density map. Thankfully, HP Tuners gave you a speed density calculator that helps you do this and puts it in a mode we're more used to. The problem is, you know, in order to do this without any other data knowing what's going on, you need to tune every single cam position in order to make this run absolutely perfect. Now, theoretically, what you can do is you can lock a few, and again, you shouldn't be seeing huge changes. You see these are minor changes in VE per cam position. So, you know, if you tune a couple and then you blend everything, that's how you can make this. But the problem is these are all torque-based ECUs. So if you get your torque model wrong, your torque model is also mapped at every single cam position, as well as the inverse torque model. And an EcoBoost, if any of this is off at all, it goes into limp mode and closes the throttle and pulls boost. So, yeah, I politely declined to tune this car. I would love to learn more, but this is great for an engine that's, and if this were a stock car, that would have been fine. The problem was this had intake swapped, it had a bigger turbo, it had as much changed as you can, and it's just not great. And that's like, I can tune this. It's going to take me X amount of days to do it where I'm comfortable, where this customer is not going to come back and say this happened or that happened and we need to retune it. And I have work lined up. They had another guy that was going to tune it for not much more than the shop I would have had to charge them for. And that did it in half the amount of time because this is all he tunes.
Yeah.
And he actually did it on Cobb, which makes it a little bit simpler. But
that's what I'm saying. Is it a platform thing with HP Tuners? Because like I've looked in a couple of EcoBoost, the trucks via SCT, and the number of tables that SCT gives you access to versus what HP Tuners gives you access to, it's got to be a third. Yeah.
So, and that's, you know, the SCT and Cobb, they make it a lot simpler. But the problem is when you start doing things that are changing these drastically, that's where they start running into problems because you can't fix this. So the benefit of HP Tuners is it gives you the access to that. The downside is you have to tune that.
Yes.
And then my bigger point here is once you get away from this equation, so if you think about that whole blow through alone, the slope of blow through. So if you change something that pretty drastically moves your VE around, that is entirely different now. So now we're completely far away from this. Now if you think about, okay, this is real cool for a stock car, and the reason it does this is it always tries to calculate and target the amount of boost that's going to give them the torque they want within the min-max limits. And that's great until you do stuff like take your electronic wastegate and blow-off valve off and replace it with a traditional wastegate and blow-off valve that can't be controlled that way. Now we're trying to run more boost. So now we're band-aiding the system into doing stuff. And this is the point, unfortunately, being a DI ECU, this is a bad example. When we start talking about needing to get off the factory system, putting a standalone on there, Because this standalone this ECU is super powerful from a factory calibration. This is amazing. But once this isn't right and this math isn't correct, this system wasn't written for the entire math equation and control scheme to change. And that's where going to, a speed density based ECU or something like that.
None of us have, unlimited budgets, climate controlled engine dyno cells that have real time, analysis to literally map themselves out with all these different scenarios. It's literally fifth and sixth dimensional crap you have to deal with, intake cam angle, exhaust cam angle, all that stuff. It's just, there are, hack ways of doing it, to get it to run okay, but
that day at the dyno,
right.
Yeah,
and that's exactly what it's still way. And that's why when I think we were talking about this earlier with some of the Coyote stuff, some of the best tuners in the world, when something goes wrong here, it kind of turns into a head scratching and okay, what happens? Because we have to go figure out where we broke this equation now.
That's dumb. I don't like it.
Drink time.
Right. I looked at this, drank a beer, called the owner in the shop and be like, do you have someone else that's willing to tune this? Is it a big deal if I don't? And he's like, if you don't want to tune it, we absolutely have somebody else. I was like, you know what? I'm going to wire 3 cars tomorrow instead of spending all my time tuning half of this car.
Looks like a lot of work.
Yeah, James was spot on. Like, the right way to do this would be to be as consistent as possible, and you need to map every single one of these in every single cam position as consistent as possible. And there's ways around it. You can blend stuff and you can get an idea. And that's, how guys are doing this, have slowly done this. But, this is going to be more and more what OEM tuning is looking like, though, because everyone's going to these torque-based systems for good reasons on the OEM. It's good for emissions. It's good for power. It's good for consistency. But what we're going to see is we start to change these more. There's going to be more and more need for I think we're going to see a lot more piggyback port injection systems, which Perdido can probably talk about some. And you're going to see more standalones, and there are standalones out there that are supporting DI, and there's more and more coming. So it's a bad news for guys that want to street their cars with CARB and EPA stuff. But the more we make these, I don't know if somebody have a whiteboard, right? Or is that me?
That was me.
Okay.
There's some new Zoom features. Sorry, go on.
But the more and more that these become this way, the harder it's going to be to really modify. They'll always be tunable, but there's going to be a limit that, taking something like this, or I don't know, on the Coyote on a factory ECU, I have a feeling like it's a similar setup, but especially on any of the boosted stuff, if you think about doing this and now make this, say this is a 2-liter, make this a 2.5, a 2.6 stroker with a different head and a different cams and a big turbo and a completely different exhaust setup, why are you going to go through all this, and how many headaches are you going to have just to get this to work?
Man,
you'll notice that some of the shops that do a lot of these later model GM, Ford, Dodge applications, they're not tuning stuff off the street anymore. They're actually doing packages for those cars in-house and tuning them.
Yeah, you have to have the parts that they suggest.
And I think the reason they're doing that is because to legitimately tune a million different combinations of camshafts, cylinder heads, turbos, whatever, on these torque-based units, you're not going to do that tune in one day. And if you can, or if you are, there's something wrong. There's something that's going to be off. So, by them doing package deals, they're just going to copy paste a tune into it and improve on each one that they do.
Right,
and that's kind of their R&D process
on this car. It's the guy's like, oh, it's this. Here's this file. Here's a base file. Let's validate. It's like, okay, that's cool. Let's make a couple fueling changes. Here you go. And it was like 4 or 5 pulls, and it was all based on packages because it's this range turbo with this setup.
Yep.
I'm going back to diesel. This is stupid. Blue, black smoke, less fuel.
You can unshare your screen if you like, because I don't know how to unshare it for you.
Nope, no,
Ask Brian to stop shared contact. Side by side mode. Got it. Okay. Cool. All right. What else is up? Get myself back up here. Oh, check out Bewley's logo, everybody. Foolproof Performance. I finally got his logo figured out and on here. Any other questions? Bill, anyone see any other questions?
I am good.
He's good to go. No one else? James, it's always good to see you again, man. It's good to see you on here. The video is nice.
Thank you.
He's getting ready to go back up to the shop.
Home and he doesn't have to be tuning until midnight.
I was going to say,
actually
usually
working on your map right now.
Something. Yeah.
I like it a lot.
Just question to all you guys. What has the lockdown done to your business? Is it slowing everybody down now, or is it taking a toll yet?
I've sold probably a quarter the amount of tuning credits this week as I have every other week this year so far. So I know that's not just an indication of my business, but all the other guys I deal with.
HP tuners, yeah, that sucks.
Yeah. It's been weird. I'm still selling some stuff, but it's definitely it comes in weird fluctuations.
I find people get bored and they'll spend some money and then it tightens up. And then it's like the money I'm getting is boredom money. I was stuck at home. I was bored. And then it's like, I want to do something. And it's weird, the roll-in right now.
I am seeing an increase in return requests and guys wanting to cancel stuff that's looking 100% like buyer's remorse stuff.
Yeah, right. Bad excuses.
Which
I might go in a different direction.
The platform to sell on because they don't give me the option to limit
poison
that.
ivy slurries.
Which
same here.
Bad. I hate saying we can't take stuff back, but I can't be eating because that's a problem. I'm eating shipping both ways.
Restocking fees, yeah. Great.
Now PayPal fees, and there's
PayPal keeps their fees now in a refund.
We're paying, in some of these cases. Yeah, in some of these cases, it's costing me anywhere from $30 to $40 for someone to change their mind on something, and some like eBay pay and a lot of the selling platforms are banning any kind of restocking fee, and even saying that if you don't allow free returns, so I pay for shipping to come back, that if I get something back that's different, I have zero recourse. Like if someone returns something without the box and I didn't give them free shipping, eBay is like, well, that sucks. If they return it this way, I can at least charge them up to a 50% restocking fee. Even if they return it open and used, I cannot deny a refund.
Wow.
I'm dealing with that with a guy right now. So you saw me look at my phone and almost swear about 20 minutes ago. Yeah, that's exactly what it was.
Corey Willis was doing a thing on this now. He's actually looking into alternatives to PayPal for the same reason, because he's starting to get people wanting to return tuning. Like, I already had an auto cal for my truck and I sold you a file and I can't afford it right now. I want to return it. It's like, how do you return? It's not like you can make sure they take the tune out of the truck.
Right. PayPal's supposed to have a policy for digital goods that are non-returnable, but it's getting worse and worse. And
PayPal jumps to the buyer's side every time.
Part of the reason they're doing that,
screw PayPal.
They're not owned by the same company as eBay anymore, and eBay is moving their own payment processor. So PayPal is just terrified of the amount of money they're about to lose. So
did you guys catch how Blake got the shaft by PayPal? This is a good reason. Like, I've normally never ever had a problem with PayPal, and then all of a sudden, Blake tells me this story. Someone tried to return a tubular Mustang front end to him or whatever, and it was a total scam. And check out how they figured this out. They returned. PayPal told them they're going to return it and you're going to give me your money back. They're like, all right, we'll wait till they return it. Well, they returned something in the box that ended up not being the product at all, and then used the signature or something, the proof of delivery from the post office or whoever it was, over the postal service, whichever one it was, I'm not sure. And then PayPal used that and gave them their money back. And that's basically how they got robbed. And then PayPal told them, go ahead and call their local sheriff or whatever. They told 417 Motorsports that.
That out as soon as
something that cost thousands of dollars.
Yeah.
That's bullshit. Yeah, I would be, I hate to say it, I'm a big PayPal guy, but I'd be shopping. PayPal? What?
yeah, I mean, if guys are seeing people move away from PayPal, don't hate on them. This is why it sucks that the few bad eggs are running it for everybody, because people also don't realize that my big spiel is credit card fraud. When people think, oh, well, my credit card company gave me my money back. No, they didn't. If someone uses a stolen credit card on my website and buys something and you file a chargeback, all your credit card company does is take that money out of my pocket. So it really sucks when people are like, oh, my kid used my credit card, I'm just going to dispute this. And unfortunately, there's zero recourse. So when you see people start doing stuff like they won't ship to a different billing and shipping address, I know Bewley is
strict about that.
Super strict about that.
Yeah, and should be.
Right. And not doing it to be a pain in the ass.
Right. No, we're not at all. It's because he's been ripped off.
Or requiring a signature
thousands of
on
dollars.
Delivery. I've had guys get real mad because I can't be home to sign for this. Well, the problem is, unless you sign for it, your credit card company doesn't consider it delivered.
Right.
It used to be PayPal actually has a limit. It's anything over like $500 or $700. But if you go with your credit card and do it, then they'll actually, if it wasn't signed for, it doesn't matter if it was $5. I'm hoping I'm not giving people ammo how to do this, but
what are they saying now with them on not getting signatures on PayPal because they don't want the drivers to have to actually meet with the person?
Yeah, so I'm not sure on that. So at a certain point, I would say if I require a signature and you don't get it, I would file an insurance claim, but I have no idea how that's going to work now.
I was thinking more from the the vendor side, where you're selling something and they're specifically not getting signatures because they're just leaving it at the door.
Right. Yeah. But normally, if I request a signature and FedEx or UPS delivers it without a signature, unless there's a signature waiver on file for that customer, usually that's grounds for me to file a claim against the shipper because they didn't meet their contractual obligation. I haven't really had that happen too much, so I have no idea how that would work right now, and I'm hoping I don't have to find out.
Well, if there's no other questions, we can let these poor folks go. If there's anybody still listening tonight. Sorry, we got a little bit of a slow start and nasty network problems. If you like what you hear, tip us at realtuners.com/tip. You guys got to check out Bewley's logo here. Boom. Foolproof performance coming soon. Jeff Salvato did that logo for him. That is badass. Nice job, dude. Does anybody have anything else to say before I run the outro music?
I think we're good.
Going once, going twice. Sold.